Hi guys, this is Carl, and this is problem number 1 for week 10. I'm just going to go ahead and get started. At a major credit card bank, the percentages of people who historically apply for the silver, gold, and platinum cards are 70%, 20%, and 10% respectively. In a recent sample of customers responding to a promotion of 200 customers, 122 applied for the silver, 52 applied for gold, and 26 for platinum. Is there evidence to suggest that the percentages for this promotion may be different from the historical proportions? So kind of off the bat, what's the expected number of customers applying for each type of card if the sample, in this sample, if the historical proportions are still true? So historical is right here. It kind of gives you what it is. Now proportions, it's kind of another way of saying percentages in this case. 70% historically, 20%, 10%. You see that a lot in survey data. You see that a lot in, for instance, sales data. So the null model gives a hypothesized proportion for each cell, and the expected value is the product of the total number of observations times this proportion for each cell. So what does that mean? So we're going to go ahead and kind of dive right into it, and you'll see right here, it really is just that. 0.7%, 70% for silver, as it's stated in the question, times 200, which is our sample size. So as you can see, 140 for silver, similarly, 0.2 times 200, you can see it up here. And then lastly, for platinum, 20, because it's 0.1 times 200. 0.1, see 10% over here for platinum cards. That's the expected value. That's the expected population, or proportion rather, based on historical proportions. So next piece of it is to compute the chi-square statistic. So the chi-square statistic is kind of helps you, it's an inferential statistic, kind of showing and comparing the populations and what you see and calculating in this equation. So for the chi-square, remember, it's the observed minus the expected squared divided by the expected. That's your chi-square. That's how you find it. And you can see it here. 122 minus 140 squared. This is squared divided by the 140. 140 being our expected value, and the 122 being our observed value right here. 122 applied for silver. And as you can see, you set those up. Similarly, 52 minus 40 squared divided by 40. And platinum, similarly, 26 minus 20 squared divided by 20. You can kind of tell as you're going along, 26 platinum here, 10% the 20 here. So that's how you get that. And we add them up, and it gets to 7.7. So you add up all the chi-squares. And how many degrees of freedom does the chi-square have? Well, remember that the k is the number of cells. And recall the number of cells in this problem are the different cards. So there's 3 cards, silver, gold, and platinum. So k minus 1 degrees of freedom, 3 minus 1 is 2. And that concludes it for problem number 1. But just let us know if you have any questions along the way. Thanks so much.